In question number 51, it is given that a wheel makes 360 revolutions in 1 minute. What is the number of radians it turns in 1 second? First of all, 1 minute equals to 60 seconds. Okay. Now, number of revolutions made by the wheel in 1 minute, that is 360, correct? Now we are going to find it 1 second, correct? So number of revolutions made in 1 second, we will divide 360 by 60, so that is 60 revolutions. Sorry, 6 revolutions. I'm sorry, 6 revolutions. Okay, 6 revolutions. 6 revolutions. Now, in one complete revolution, it makes 360-degree angle, right? So, if 180-degree angle is pi radian, then 360-degree angle is how much radian? We have to find that. So that is 2 pi radian. So 360-degree angle. So the wheel in complete revolutions, the wheel turns 2 pi radian angle. Okay, so hence in 6 revolutions it will turn, hence in 6 revolutions, 6 complete revolutions, it will turn an angle of 6 multiplied by 2 pi radian. So that is 12 pi radian. So here the correct answer is option C is the correct answer. What is the number of radians it turns in 1 second? 12 pi radian. In question number 52, we are given with what is the least value of 25 cosec square plus 6 square x? 25 cosec square x plus 6 square x. First of all, the concept you are going to use here, minimum value of m sec square theta plus n cosec square theta, that is equals with root under m plus root under n whole square. Okay, so here n is given. Let me first write the given expression, that is 25 cosec square x plus 6 square x. So here n is 25 and m is 1. Therefore, the minimum value of 25 cosec square x plus 6 square x, that is root under 25 plus root under 1 whole square. So 5 plus 1 whole square will be result in 36. 6 whole square 36. So here option B is the correct answer, 36. In question number 53, it is given that let theta belongs to 0 degree to 90 degree and 100 theta equals to 90 degree. If alpha equals to multiplication sigma from starting from n equals to 1 to 99 cot n theta, then which one of the following is correct? So here we are given alpha equals to multiplication sigma n equals to 1 to 99 cot in theta. So since this is multiplication sigma, we can further express alpha as cot theta multiplied by cot 2 theta multiplied by cot 3 theta multiplied by cot 4 theta dot 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 up to cot 98 theta multiplied by cot 99 theta, because n is continuing till 99, and also it is given that 90° equals to 100 theta. Now with the complementary angles formula, we know tan theta equals to cot 90° minus theta. So further I can write cot 100 theta minus theta. In place of 90, I can write 100 theta. So it becomes cot 99 theta. So tan theta equals to cot 99 theta. Same way, tan 2 theta, I can write cot 100 theta minus 2 theta. So that would result in cot 98 theta. So same way, tan 3 theta result in cot 97 theta. Okay. So here, let me write it properly, cot 98 theta. Fine. So, and so on, we can get it. So hence we can find the above expression as also, let me tell you one thing, tan theta multiplied by cot theta gives us 1 because they are reciprocal to each other. So therefore alpha equals to cot theta multiplied by cot 2 theta multiplied by cot 3 theta dot dot dot. If we can write cot 49 theta multiplied by cot 50 theta. Next, starting from cot 51 theta, we can again write tan 49 theta. So cot 52 theta, we can write tan 49 theta. So 48 theta, and up to we can continue it as tan 2 theta multiplied by tan theta in terms of cot 99 theta. So since tan theta and cot theta, they are reciprocal to each other, so both cot theta tan theta will give us 1. So this will become 1 1 1 dot 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 up to only cot 50 theta will be there. So alpha becomes cot 50 theta. Okay. Now, since it is given that 100 theta is equals to 90°, so 50 theta is equals to 45°. So that means alpha equals to cot 45°, which results in 1. Therefore, the value of alpha, that is multiplication sigma in 1 to 99 cot in theta, will result in 1. So here the correct option is, yes, A. Option A is the correct option. A equals to 1. This must be alpha. In question number 54, we are given with if tan 6 theta equals to cot 2 theta, where 6 theta lies between theta to pi by 2. So here, then what is the value of sec 4 theta? This must be 0°. So 0 to pi by 2, what is the value of sec 4 theta? Now we can use this formula, cot theta equals to tan 90° minus theta. We are going to use this concept. So since here we are given tan 6 theta equals to cot 2 theta, cot 2 theta can be written as tan 90° minus 2 theta equals to tan 6 theta. So further since both side are having 10, we can cancel it out. So we will have 6 theta equals to 90 degree minus 2 theta, 8 theta equals to 90 degree. So 4 theta equals to 45 degree. Therefore, sec 4 theta, that is sec 45 degree, would result in root 2. Here option A is the correct answer. In question number 55, it is given that a tree of height 15 meter is broken by wind in such a way that its top touches the ground and makes an angle 30 degree with the ground. What is the height from the ground to the point where the tree is broken? I have already drawn the scenario, the figure. So here AD is the tree where at B point it is broken and touches the ground at the point C. So it makes 30 degree angle. AD is 15 meter. So if I assume let the height from the ground to the point where the tree is broken, that is, let's say x meter. So this is x meter since the complete height is 15. So this is 15 minus x meter. So in triangle ABC, we can write AB by BC perpendicular by hypotenuse, that is sine 30 degree if we consider angle C. So here ABX and this is 15 minus x, sine 30 degree will give us the value half. So it is 2x 15 minus x, and further if I continue, we will get 3x equals to 15. So x equals to 5. So hence the height from the ground to the point where the tree is broken, that is 5 meter. So here option C is the correct answer. In question number 56, we are given with on a plain area, there are two vertical towers separated by 100 feet apart. So AC, here AC and DG, these two towers. Okay, the shorter tower is 40 feet tall. So here DG is the shorter tower. So we can write DG is 40 feet. A pole of length 6 feet stands on a line joining the base of these two towers so that the tip of the towers and the tip of the pole are also on the same line. AGF are on the same line. So here EF is the pole that is of 6 feet. If the distance of the pole from the shorter tower is 75 feet, so here DE is 75 feet, then what is the height of the taller tower approximately? We are asked to find the value for AC. So if we first consider the triangle GHF, so we can write here, first of all, GH is DG minus DH, where DG is 40 feet and DH is equals to EF, so that is 6 feet. So the value for GH is 34 feet. And here FH is equals to EDE, that is also 75 feet. Now we know tan theta is perpendicular by base. So tan x is GH by HF. So here GH is 34, HF is 75. So we got the value of tan x 34 by 75. Let's name it equation number 1. Next, if we consider the triangle ABF, so triangle ABF, where AB by BF equals to tan x. Now, how to find BF? BF is equals to BH plus HA, where BH is equals to CD according to the picture, according to the diagram. So we can write 100 plus 75 feet. So that would result in BF would result in 175 feet. So let's put all the value here. AB by 175 equals to, now from A, we can write the value of 10x, that is 34 by 75. Okay, from 1. Now the value of AB is 34 multiplied by 175 by 75. So 3 and 7. Now it would result in 79.33 feet. That is AB. But the tower is AC, where BC is also equals to 6 feet. So the height of the taller tower, so AC is AB plus BC, 79.33 plus 6 feet, that is 85.33, or we can write 85 feet approximately. So the height of the taller tower is 85 feet approximately. Option A is the correct answer. In question number 57, we are given with the angles of elevation of the top of tower from 2 points at distance P and Q from the base and on the same straight line are 27° and 63° respectively. What is the height of the tower? I am already done with the diagram. Here AB is the tower whose height is H, and this C and D, these are 2 points. Okay, so from C, the tower is at P distance, from D, the tower is at Q distance. So here, the formula or the concept that we are going to use, those are tan theta equals to cot 90° minus theta. The first one is, and tan theta is perpendicular by base, cot theta is base by perpendicular. Also, tan theta is 1 by cot theta. And so here we are given BC equals to P unit, BD equals to Q unit. Okay, so in triangle ABD, we can write tan 63° equals to AB by BD. So here H by BD, that is Q. So H by Q, we can write let height of the tower be H. Okay, and now in triangle ABC, tan 27° is AB by BC, that is H by P. Okay, now also from here we can find cot 27°, that is the reciprocal of tan 27°. So that will be P by H. So we know tan 63° can be written as tan 90° minus 27°. So we can write from here, that is cot 27°, because cot theta equals to tan 90° minus theta. Okay. So from here, this is cot 27°. So we know tan 60° is H by Q. Let's put here P by H. So after doing the cross multiplication, we'll get H square equals to PQ. Okay, so that means H equals to root under PQ. So this is the height of the tower, root under PQ. So we got the value of H, that is root under PQ. Option B is the correct answer. In question number 58, we are given with what is the value of sine square 6 degree plus sine square 12 degree plus sine square 18 degree, and this way up to sine square 90 degree. So the concept we are going to use here, that is sine 90 degree minus theta equals to cos theta, and also sine square theta plus cos square theta equals to 1. These two concepts we will use. Now first let me write the given expression: sine square 6 degree sine square 12 degree sine square 18 degree plus dot 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 sine square 78 degree plus sine square 84 degree plus sine square 90 degree. As we can see, started from 6 and up to 90, all theta, every theta has a gap of 6 degree, correct? So with the help of AP, we can find how many terms are there. So 90 degree equals to, since the formula you're going to is, that is which term is 90 degree. So let's say nth term is 90 degree. That means 90 degree plus 6 plus n minus 1. D is here 6 because there is a gap of 6 degree. So yes, 84 by 6 n minus 1. I will get here 14. So 90 degree starting from 6 minus plus 1 by 6 n equals to 15. So 90 degree is 15th term. Okay, 90 degrees 15th term. So I can write here. So here we can see 15 terms are there. Next, sine square 6 degree. We will keep them as it is. Next, we will start changing after now from the end part dot dot dot. Now sine square 78 degree can be written as sine square 90 degree minus 12 degree, correct, plus sine square 90 degree minus 6 degree plus sine square 90 degree. I will keep like this way because we know the exact value of sine square 90 degree. Now sine square 6 degree, sine square 12 degree, sine square 18 degree, and plus dot dot dot. Now sine 90 degree minus theta, that would give us cos theta. So it'll become cos square 12 degree plus cos square 6 degree. And the last one is sine square 90 degree. So we can take pair sine square 6 degree, cos square 6 degree. Okay, next sine square 12 degree plus cos square 12 degree. Next sine square 18 degree plus cos square 18 degree. Okay, and this way it will continue and we will get still sine square 42 degree plus cos square 42 degree plus sine square 90 degree. Okay, so yes, now we can see here we will get now sine square theta plus cos square theta will give us 1. So for this values we can put 1. So here we will get, and also sine 90 degree, value of sine 90 degree, that is also 1. So there we can see, yes, 8 1 we will get 1 2 3 4 5 6 7 8 8 1 we will get. So the value of this expression is 8. Option D is the correct answer. In question number 59, we are given with what is the value of cos theta by 1 plus sin theta plus 1 by cot theta. Let me write the given statement, that is cos theta by 1 plus sin theta plus 1 by cot theta. We know cot theta cot theta means cos theta by sin theta, right? So it will become sin theta by cos theta. Now let's do the LCM. So here 1 plus sin theta cos theta. Now this will become cos squared theta plus this will become sin theta multiplied by 1 plus sin theta. So here cos squared theta plus sin squared theta plus sin theta by 1 plus sin theta multiplied by cos theta. So cos squared theta plus sin squared theta 1. So it becomes 1 plus sin theta in the numerator, and also there is 1 plus sin theta in the denominator as well. Both will get cancelled. We will left with 1 by cos theta, that is sec theta. So here the correct option is option B, sec theta. In question number 60, we are given with what is the value of this expression. Let me first write the given expression. Sin theta minus cos theta plus 1 by sin theta plus cos theta minus 1 minus of sin theta plus 1 by cos theta. So here let's do the LCM. Sin theta plus cos theta minus 1 multiplied by cos theta. So here we will get sin theta cos theta minus cos squared theta plus cos theta minus sin squared theta plus sin theta cos theta minus sin theta and plus sin theta plus cos theta minus 1. So from here we can see, okay, so it will become minus sin squared theta, and also, okay, so please make a correction. Here we will get so minus of sin square theta and minus plus minus sin theta cos theta. Okay, next that is minus minus plus sin theta, and next that is again minus sin theta minus cos theta and plus 1. Yes, this is the result. Now we can see sin theta cos theta will got cancelled. Plus cos theta minus cos theta will got cancelled here. And sin theta minus sin theta will got cancelled. If we take common minus, it will become sin squared theta plus cos squared theta plus 1 by sin theta plus cos theta minus 1, that is cos theta. So minus 1 plus 1 by sin theta plus cos theta minus 1. So cos theta both my 1 got cancelled, so we'll get 0. So the value for this given expression is 0. Here option A is the correct answer. In question number 61, we are given with an expression. We need to find the value of this expression. Let me first write the given expression, that is 10x plus 10y 1 minus cot x cot y plus cot x plus cot y multiplied by 1 minus 10x tan y. We are going to find the formula, that is tan x is reciprocal of cot x. Also, tan y is also reciprocal of cot y, and vice versa. Cot y is reciprocal of tan y. So here, let me first write the first line. I will change this cot x and cot y into tan x and tan y. So it will become tan x plus tan y 1 minus 1 by tan x tan y plus 1 by 10 x plus 1 by 10 y multiplied by 1 minus 10 x tan y. So here we will do the LCM, and tan x plus tan y by 10x tan y. So it will become 10x tan y minus 1. Next plus, so here we have 10x tan y and 10x plus tan y multiplied by 1 minus 10x tan y. Next, if we take common here, we will get minus common. So it would become 10x plus 10y, 1 minus 10x tan y by 10x tan y. Next, plus, in denominator we have 10x tan y, in numerator we have 10x plus tan y multiplied by 1 minus 10x tan y. So here we can see that both expression are same. One is positive, one is negative. So both will cancel out. We will get 0. So 0 is the value for the given expression. Here option A is the correct answer. In question number 62, we are given with what is the value of root under sec x minus tan x by sec x plus tan x. Let me first discuss the trigonometric identities that we are going to use, that is sec square x minus tan square x equals to 1. Also, one algebraic formula we will use, that is a plus b, and a minus b will give us a square minus b square. So here we are given with sec x minus tan x by sec x plus tan x. If we multiply both numerator and denominator by sec x plus tan x, it will become sec x minus tan x multiplied by sec x plus tan x by sec x plus tan x whole square. Okay, so here we can see it is in the form of a plus b, a minus b. So we can write it as a square minus b square, that is sec square x minus tan square x by sec x plus tan x whole square. It would result in 1. So root under 1 by sec x plus tan x whole square, right? So if we take it out from the root, if we square root it, we will get 1 by sec x plus tan x. So this is the answer here. It matches with option C, 1 by sec x plus tan x. In question number 63, we are given with if theta lies in the first quadrant and cot theta equals to 63 by 16, then what is the value of sine theta plus cos theta? So first we know, let's say this is a right angle triangle A, B, C and right angle at B. Okay, so cot theta means we know cot theta equals to BC by, if this is theta, so this is BC by AB, that is base by perpendicular. So here BC, it is already given 63 by 16. So we can assume 63 as BC as 63K and AB as 16K, where K is the ratio constant. Okay, K is the ratio constant. So here this is 16K and this is 63K. So by Pythagoras rule, we can find, by Pythagoras rule, we get the value of AC root under 16K whole square plus 63K whole square. It would result in 65K. So we got the value for hypotenuse, that is 65K. Now in first quadrant, we know all trigonometric ratios are positive. Okay, so here sine theta is perpendicular by hypotenuse, so that is 16K by 65K. Also with sine theta we are required to find cos theta. Cos theta is base by hypotenuse, that is 63K by 65K. Now let's find the value for sine theta plus cos theta. 16 by 65 plus 63 by 65. So here 16 plus 63, that would result in 79 by 65. So here the value for the given expression sine theta plus cos theta, that is 79 by 65. Here option C is the correct answer. In question number 64, it is given what is the value of 1 minus 2 sine square theta cos square theta by sine to the power 4 theta plus cos to the power 4 theta plus 4 equals to. So here we are going to use one formula, that is a plus b whole square minus 2ab equals to a square plus b square. Okay, now let me write the given expression, that is 1 minus 2 sine squared theta cos squared theta by sine to the power 4 theta plus cos to the power 4 theta. So also we know sine squared theta plus cos squared theta equals to 1. So in place of 1, we can write sine squared theta plus cos squared theta minus 2 sine squared theta cos squared theta by sine to the, and also plus 4. Let me write this side plus 4. So here sine to the power 4 theta plus cos to the power 4 theta. Now look here, it is in the form of a plus b whole square. One whole square will give us another one. So we can write sine square theta plus cos square theta whole square. Now a plus b whole square minus 2ab. That would result in a square plus b square. So here a is sine square theta. So that means sine square theta whole square. Next cos square theta whole square by sine to the power 4 theta plus cos to the power 4 theta plus 4. So it would become sine to the power 4 theta plus cos to the power 4 theta by sine to the power 4 theta plus cos to the power 4 theta plus 4. This would get cancelled. 1 plus 4, it would result in 5. So here the value for the given expression, that is 5. Option D is the correct answer. In question number 65, we are given with a rectangle is 48 centimeter long and 14 centimeter wide. I have already done with the diagram. If the diagonal makes an angle theta with the longer side, then what is the value of sec theta plus cosec theta? So here I have done with the diagram. So here 48 is the longer side, 14 is the width. I have to find the length of the diagonal. Since this is right angle triangle, if I name it A, B, C, D, B is right angle. Since this is a rectangle, so ABC is a right angle triangle. Now by Pythagoras theorem, I can find the value of hypotenuse, that is AC, which is root under 48 whole square plus 14 whole square. It would result in 50. So this is the length of the diagonal. Now we know sec theta is hypotenuse. In short, I'm writing only H. Hypotenuse by base. In short, I'm writing only B. And cosec theta is hypotenuse. In short, I'm writing only H by perpendicular. In short, I'm writing only P. So in order, if we consider theta, so in order to find the value of sec theta and cosec theta, we'll get sec theta equals to AC by AB, that is 50 by 48, and cosec theta is AC by BC. So 50 by 14. So the sum of these two values, sec theta plus cosec theta, is 50 by 48 plus 50 by 14. If I solve them, I will get here 50. I can take common 2. It would become 1 by 24 plus 1 by 7. So this would result in 25. Here I can get the LCM of 24 and 7, that is 168. 168. 7 plus 24. So 25 multiplied by 31 by 168. That would result in 771 by 168. This is the answer. The value for this sec theta plus cosec theta, 771 by 168. Here 770. Okay, so yes, sorry, this is not 771. If we multiply 25 with 31, we will get 775. Please make the correction. The correct answer is 775 by 168. If we do the multiplication, we will get 775 by 168. Yes, please make the correction. Here option A is the correct answer. In question number 66, we are given with what is the area of the triangle having side lengths y by z plus z by x. One side, another side is z by x plus x by y, and the third side is x by y plus y by z. If I first discuss the concept of area of a triangle, so let's say this is a triangle, its side is ABC. So we know what is the semi perimeter of it, that is S, A plus B plus C by 2. Now the area of triangle by Heron's formula, we can find root under S minus A, S minus B, S minus C. This is the formula, and this particular formula we are going to use here. So we are given that the sides are y by z plus z by x, z by x plus x by y, x by y plus y by z. So first we will find the semi perimeter, that is S. Let's add all of them. X by y plus y by z by 2. So it becomes 2 twice of y by z plus z by x plus x by y by 2. So the value of semi perimeter is y by z, z by x plus x by y. Therefore, area, we will use this particular formula, root under s of s minus a. Here we can say a is y by z plus z by x, b is z by x plus x by y, and c is x by y plus y by z. Now, if we find root under s, that is y by z plus z by x plus x by y. Now s minus a, we will left with only x by y. Next, s minus b, we will left only y by z. They are all multiplied, and s minus c, we left only z by x. Now look here, all this x, y, z will got cancelled. We are left with y by z plus z by x plus x by y. Okay, so this is the answer. Also, I'm writing here, this is the answer. Also, I'm showing here x is by a, x plus y plus y plus z plus by x minus y by z minus z by x. So this two will got cancelled, only x by a will left. So similarly, we can find x is by minus b, s minus c as well. So here the area of the triangle is root under y by z plus z by x plus x by y. Here option C is the correct answer. In question number 67, it is given that if the angles of a triangle are 30° and 45°, and the included side is root 3 plus 1 centimeter, then what is the area of the triangle? So we are given with two angles. So from angle sum property, we can find the angle A, that is 180° minus 45° plus 30°. So it is 105°. Angle A is 105°. Now we have drawn a perpendicular AD. That means this is 90°. So it will become 45°, and this will 60°. Okay, now in order to solve this question, we are going to use some concepts. Those are the value for tan 30°, that is 1 by root 3. Also tan 45°, that is 1. And the formula of area of triangle. Area of triangle formula is half into base into height. Okay, so now look here, in triangle ABD, we can assume, let BD as X unit, okay, and here AD as H. Since this is a right angle triangle, so we can write in ABD tan 45°, that is H by X. Therefore, H equals to X. Let's name it equation 1, because this is tan 45° value 1. And also now triangle ACD, we can see triangle ACD. So since the total BC is root 3 plus 1, root 3 plus 1. So this is root 3 plus 1 minus 6, the length of CD. So now we can write AD by CD tan 30 degree. So AD here H by CD here root 3 plus 1 minus X tan 30 degree means 1 by root 3. So now we are going to use this formula. So here we can write that 1 by root 3. So it will become root 3h root 3 plus 1 minus x. Correct. So from here, now from 1, I can put x here also in place of h. So it will become root 3x plus x and root 3 plus 1. Now from 1, I am putting h equals to 1. Now after taking, so here root 3x root 3 plus 1, we can write, after taking common x, it's become root 3 plus 1 equals to root 3 plus 1. Both root 3 got cancelled. So here x equals to 1. Therefore, we can write h equals to also 1. So here h is the height of the triangle. Correct. Now we know how to find the area, half into base into height. This AD height is lying on the base BC. So we can write, therefore, area of triangle, that is half height h multiplied by base BC. Now we will put all these values, half into 1 into root 3 plus 1. The unit is centimeter square. Centimeter square. So here this is root 3 plus 1 by 2 centimeter square. This is the area of the triangle. Now let me check with all the options. Yes, options is the correct answer, root 3 plus 1 by 2 centimeter square. In question number 68, we are given with ABCD is a plate in the shape of a parallelogram. EF is the line parallel to DA. I have already done with the diagram, and passing through the point of intersection O of the diagonals AC and BD, where E lies on DC and F lies on AB. The triangular portion DOE is cut out from the plate ABCD. I have already shaded this portion to make it easier, to make it understand easier for you. What is the ratio of area of remaining portion of the plate of the whole? Okay, so here we can see, if we suppose the complete area of the parallelogram, look here how many parts we are dividing it. If we suppose the complete area of the parallelogram is 8 units, let's suppose if we suppose the complete area of ABCD, this parallelogram, is 8 units, then diagonal BD will divide it into 2 equal parts. Okay, BCD and ABD. Then diagonal BD will divide it in 2 equal parts. Okay, so this will become 2 part and this will become okay, so here BCD will become 4 units first of all. So area of ABD equals to area BCD, that is 8 by 2, 4 units. Okay, now further we can see CO is there. So further CO will divide triangle BCD CD in two equal parts. Two equal parts, that is BCO and COD, right? So here, so triangle BCO and okay equals to triangle, not and, equals to triangle COD, that is 4 by 2, 2 units. So this much part is 2 unit because we have again parted this COD by OE. Okay, now this is 2 units. So here we can say, now it is given that EF is parallel to DA. EF is line parallel to DA. So EF is parallel to DA. Okay, so here we can say AD equals to EF also. So AD equals to EF also. Now EO, now this line EO will divide COD into two equal parts, this two parts COE and DOE. Therefore, EO will divide triangle DOC or COD in two equal parts. Therefore, area of triangle DOE is 2 by 2, that is 1 unit. So here DO is 1 unit and this is another 1 unit. All total they are 2 units. Now when DOE is out of this parallelogram plate, we will left out only this much part. So here this is 4 units, this is also 2 unit, 1 unit, 1 units, this is 4 unit, this is 2 unit, and this is 1 unit. So all together we can say 7 units. Now when DO is out, when triangle DOE is cut out from the plate ABCD, then ratio of area of remaining portion to the whole, that is remaining portion is 8 minus 1 unit, because 1 unit we are removing from the plate. So 8 minus 1 is to 1, that is 7 is to 8. This is the area of the remaining portion to the whole plate, 7 is to 8. Okay, so here 7 is to 8 means 7 by 8. So option D is the correct answer, 7 by 8. In question number 69, we are given with this two circles of radius 20 centimeter and 16 centimeter intersect, and the length of common chord is 24 centimeter. I have already drawn it here. AB is the common chord, that is of 24 centimeter. So AB is 24 centimeter, and here PA is the radius of the larger circle. So PA is 20 centimeter and AQ is the radius of the smaller circle, that is 16 centimeter. If D is the distance between two centers P and Q, then which one of the following is correct? So since here the radius made a right angle on the chord, so here ARP is right angle. Angle ARP and angle ARQ, both of them are right angle 90 degree. So we can use here Pythagoras theorem, correct? Also, since the length of the common chord is 24 centimeter, we know the line, we know that the line joining the centers joining the centers of two intersecting circles, is perpendicular to the common chord, and it also divides the chord in two equal parts. Okay, so here R is the midpoint, we can say, because the line that is joining P and Q, that will bisect the AB into two equal parts. So here AR equals to RB, and that is 24 by 2, 12 centimeter. Okay, now in right angle triangle APR, we can write AP squared equals to AR square plus PR square. We are going to find out the value for PR square, that is AP square minus AR square. So PR is here AP is 20 whole square, that is 400, minus AR is 12 whole square, so that is 144. It will result in 16. So PR is 16 centimeter. Similarly, for this smaller triangle ARQ, we can write here QR square. Here QR square equals to AQ square minus AR square. That is 16 whole square minus 12 whole square. So QR is root under 256 minus 112. So that would result in root under 112, or the value of QR is 10.58 centimeter. Okay, 10.58 centimeter. So we got the value of PR and QR, correct? PR and QR. To get PQ, hence the required distance, that is PQ, we can write PR plus RQ. So 16 plus 10.58 centimeter, that would result in 28.58 centimeter. So here obviously 26.58 centimeter is lying between 26, okay, 26.58 less than 27. So here we can say if the distance is D is the distance of their centers, so that means this is D. So 26 less than D less than 27, we can say that. So here, yes, option B is the correct answer. 26 centimeter less than D less than 27 centimeter. Option B is the correct answer. Again, I want to show you the entire solution. In question number 70, we are given with, in a circle of radius 5 centimeter, AB and AC are two chords such that AB equals to AC equals to 8 centimeter. I'm done with the diagram. So here AB and AC are two chords, both are of 8 centimeter. Here O is the center, and OA, OB, these all are 5. OC, these all are 5 centimeter because these all are radius. Now we have drawn a perpendicular from the center on the chord BC. So it becomes OD, touches the chord at the point D. Okay, so here we can say AB equals to 8 centimeter, AC equals to 8 centimeter, and we can find OA, OA, OB, OC. These all are 5 centimeter. Okay. Now we know that perpendicular, we know the perpendiculars perpendicular from the center, perpendicular from the center of a circle, from the center of a circle on the chord BC, on the chord, divides the chord into two equal parts, divides the chord in two equal parts. Okay, so here OD is the perpendicular, OD is perpendicular on BC. Okay, so we are getting here ACD, ACD or ABD. Okay, ABD and ACD, these two are right angle triangle because this is right angle. So here ABD and ACD, these two are right angle also. Triangle ABD, and look at the smaller one, B, here is O, BOD, triangle BOD. These two are right angles. Okay, right angles. Now we can assume that the length of BD as Y and the length of OD as X. So we don't know the value for BD, so let's say Y centimeter and OD is X centimeter. So by Pythagoras theorem, now we can write by Pythagoras theorem, we can write from ABD, that is X plus 5, X plus 5 whole square plus Y square equals to 8 whole square. So further we can write Y square equals to 64 minus X plus 5 whole square. And also from BOD we can write X square plus Y square equals to 5 whole square. That means Y square equals to 25 minus X square. 25 minus X square. Now let's name it 2 and 1. So from these two equations, since these two are giving us the value of Y squared, we can equate them. 25 minus X square. So now let's solve it to get the value of X. 10X, 5 minus X square. So here we are having 64 minus 25. Okay, also minus 25. We are having 10x. So this would result in 64 minus 25, 29, right? 29, rather 64 minus 50. Yes, that is 14. So 10x minus 14. From here we can write x equals to 14 by 10, that is 7 by 5. So we got the value of x, that is 7 by 5. Therefore, y is, we know y square 25 minus x square. So that is 25 minus 49 by 25. That would result in 576 by 25. That is 24 by 5. The value for y is 24 by 5. Therefore, chord BC. Now, since D is the midpoint, because the perpendicular from center divides the chord BC into two equal parts. So here D is the midpoint. So we can say BD equals to DC. So therefore BC is now twice of BD. Okay, so twice of A, that is 24 by 5, that is 48 by 5 centimeter, or the resulting 9.6 centimeter. So yes, the length of chord BC is option C, that is 9.6 centimeter. Option C is the correct answer here. In question number 71, we are given with two circles touch internally. The sum of their areas is 136 pi centimeter square, and the distance between their centers is 4 centimeter. What are the radius of the circle? There will be no R. Okay, so I have already done the figure. Two circles are touched internally. One is larger one is smaller circle. Capital R is the radius of the larger circle, and the small r is the radius of the smaller circle. O1, O2, these are the centers of larger circle and smaller circle respectively. So here, since the distance between their centers is 4 centimeter, that means capital R minus small r, that is 4 centimeter. So from here, I can write capital R equals to 4 plus R centimeter. Now, their sum of their areas 136 pi, right? So since we can find the area of the of two circles, so that is area of the larger circle pi capital R square, and area of the smaller circle pi small r square. So now pi capital R square plus pi small r square, that is 136 pi. So now we can write the value of capital R in terms of small r, 136 pi. All pi will got cancel. R square 16, 8r plus r square equals to 136. So we can write 2r square plus 8r minus 120. We will get r square plus 4r minus 60. If we factorize this, we will get r square plus 10r minus 6r minus 60. So that is r plus 10 and r minus 6. Okay, r minus 6 equals to 0. So r equals to 6. We got the value of small r, that is 6 centimeter. So the radius of the small circle, that is 6 centimeter. Therefore, the radius of the larger circle, that is 10 centimeter. So 10 centimeter and 6 centimeter. These two are radius. What are the radius of the circles? 10 centimeter and 6 centimeter. Option B is the correct answer. In question number 72, we are given with if area of a circle and a square are same, then what is the ratio of their perimeters? Let me draw a circle first. Let's say the radius is small r, O is the center, and here let me draw a square. So here the length of one side is a unit. Okay, now area of the circle, the formula for finding area of circle, that is pi r square, and area of square, that is a square. Okay, side into side, a square. Now these two are equal. So we can write pi r square equals to a square. Now what is the ratio of their perimeters? So here from this we can write r squared by a square equals to 1 by pi, or r by a equals to 1 by square root pi, root under pi. Okay, now what is the ratio of their perimeter? So perimeter of a circle, that is the circumference of the circle, which is 2 pi r, and perimeter of square, the formula is 4a. So we are required to find the ratio of their perimeters. Therefore, ratio of perimeters 2 pi r is to 4a. So from here we can write 2 pi r by 4a. It will become pi by 2 r by a. From 1 I can write r by a as 1 by root under pi. So this will become root pi by 2. Okay, so here the ratio is root pi is to 2, or root pi by 2. So yes, option C is the correct answer. Root pi by 2 is the correct option. In question number 73, it is given that a circle of diameter 8 centimeter is placed in such a manner that it touches two perpendicular lines. Then another small circle is placed in the gap such that it touches the lines and the circle. What is the diameter of the smaller circle? So we know the relation between radius and diameter, that is radius, we will get radius if we divide diameter. If we divide diameter, correct? So here in this figure, we can see, let's say A and B, these two are centers of the circles. A and B are the centers of the circle. Okay, so therefore radius of this bigger circle, which is AP, since diameter is 8 centimeter, so radius will be 8 by 2, which is AQ as well, so 4 centimeter. Now suppose radius of smaller circle, radius of smaller circle, that is 8 centimeter. Okay, now in this square APOQ, okay, so in APOQ, this is a square. So we know the side is 4 centimeter. The side is 4 centimeter, and there is a relation for the square that diagonal is equals to a root 2, where a is side. Okay, for only square. Now since this is a square, so its diagonal is AO, correct? So diagonal AO is 4 root 2 centimeter. Now look at another square, which is BCOD. Okay, so in BCOD, diagonal BO, since the side is x, so x root 2 centimeter, correct? Now both the circles touch each other at the point S. Both the circles touch each other at point S. Okay, so here AS is the radius of the largest circle as well. That means A is 4 centimeter. And SB, what is SB here? Let me check. Here SB is the radius of the smaller circle, which is X centimeter. Now we can say AO is equal to AS plus BS plus BO. AS plus SB plus BO. We'll put all these values. 4 plus x root 2. Here this is 4 root 2. Now let's solve it. 1 plus root 2, 4 root 2 minus 1, or x equals to 4 root 2 minus 1 whole square. Here root 2 plus 1 and root 2 minus 1. So it is 2 plus 1 minus 2 root 2. Here we will get 2 minus 1 because it's in the form of a plus b multiplied by a minus b equals to a square minus b square. The denominator is in this form. So we will get the value of x, that is 4, 3 minus 2 root 2. Okay, so here x is the radius of the smaller circle. We are asked to find the diameter of the smaller circle. Therefore, diameter of the smaller circle that is 2x, 2 multiplied by 4, 3 minus 2 root 2, that is 8 multiplied by 3 minus 2 root 2 centimeter. So let me check the options. 8 of 3 minus 2 root 2. Here option D is the correct answer. 8 of 3 minus 2 root 2 centimeter is the correct answer. In question number 74, we are given with the thickness of a cylinder is 1 foot and the inner radius of the cylinder is 3 feet and the height is 7 feet. To paint the inner surface, it requires 1 liter of particular color. How much quantity of the same color is required to paint all the surface of the cylinder? Let me first write down all the given informations. Those are inner radius 3 feet. Let's name it capital, smaller. Thickness, that is 1 feet, and height, which is h, that is 7 feet. Now we know the formula for surface area of a whole cylinder. Surface area of whole cylinder 2 pi capital RH plus 2 pi small rh plus 2 pi r square minus r square. Okay, so we can find here capital R is outer radius. So let's find out the outer radius first. Outer radius capital R is inner radius plus thickness, so that is 4 feet. Okay, now we can put all the values there. We'll get the value for surface area of whole cylinder. Whole cylinder, that is 2 pi 4 multiplied by 7 plus 2 pi 3 multiplied by 7 plus 2 pi 4 square minus 3 square. So it is 856 pi plus 42 pi plus 14 pi. Okay, so here we will get 16 minus 9, 7, 14 pi. So all total it is 112 pi. Now it is given in the question that to paint the inner surface, it requires 1 liter of that particular color. So inner surface area of inner surface, that is 2 pi small rh, so which is 14 multiplied by 3 pi 42 pi. Therefore, paint required for, okay, first of all, paint required for 42 pi area 1 liter. Therefore, paint required for 112 pi area 112 pi by 42 multiplied by 1, 42 pi multiplied by 1, the answer is 8 by 3 liter. So here we will get the answer. Option C is the correct answer here, 8 by 3 liter. Question number 17, it's given that a square and a rectangle have equal areas. If one side of the rectangle is of length numerically equal to the square of the length of the side of the square, then the other side of the rectangle is. So it is given that one side of the rectangle is numerically equal to the square of the length of the side of the square, right? First of all, the two formulas we are going to use here, that is area of square, so which is side whole square, and next is area of rectangle, length into breadth. Okay, so we can assume that let's say length and breadth, suppose length and breadth of rectangle are L, L and B, and also side of the square is X centimeter. Okay, so since it is given that one side of the rectangle is numerically equal to the square of the length of the side, so we can say according to the problem L equals to X square. Okay, also it is given that area of rectangle and square are equal, both of are having same area, so L into B equals to X square. Now in place of X square we can write L, so we can write L multiplied by B, L, both L with got cancelled, so here we will get B equals to 1. Other side of the rectangle is 1 unit, so here the correct answer is other side of the rectangle is of unit length. Option C is the correct answer here. In question number 76, the question is given the length and breadth of a rectangle are in the ratio 4:3. Then what is the ratio of the area of the triangle formed by the parts of the diagonals with a long side to the area of the triangle formed by the parts of the diagonals with a short side? Let me explain it. ABCD is a rectangle. Okay, so the length and breadth ratio is given, that is 4 is to length is to breadth is given 4:3. Okay, now here AC and BD, these two are diagonals, correct? Now what is the ratio of the area of the triangle formed by the parts of the diagonal with the longer side? What is the longer side here? AB and CD, these two are longer side. So a triangle which is which formed by that longer side, and here BC and CD are shorter side. So like BOC is the triangle or AOD is the triangle which formed with the shorter side. We are going to find the area of this two triangle. Also, we know area of triangle is equals to half into base into height. Okay, so now let's consider these two triangles. Since length and breadth ratio is given, let length AB equals to CD, we can say 4x, and breadth, that is AD, equals to BC, which is 3x, where x is ratio constant. X is ratio constant, correct? Now, since O is the intersection of point of diagonals and the center of the rectangle, O is the point of intersection of diagonals and the center of rectangle, correct? So we can write OX will be half of AB. That means it is 2x. Okay, and OY is half of AD or BC, half of BC, 3x by 2. Now look at the triangle COD or BOC. Okay, so area of triangle COD, half into CD into OY, half into 4y into here OY, okay, not y, sorry, it will be 4x, and OY is 3x by 2, 12. Okay, not 12, we can simplify it, 3x square. Okay, and area of triangle BOC is half into BC into OX, that is half into, where is BC? The value of BC is 3x multiplied by 2x. So that is again 3x square. Okay, we are having the area same. Therefore, ratio longer side with the shorter side, both are same. So 3x square is to 3x square, we will get 1 is to 1. So here correct option is D, 1 is to 1. In question number 77, it is given that suppose a region is formed by removing a sector 20 degree from a circular region of radius 30 feet. What is the area of the new region? First of all, what is a sector in a circle? So a closed part of a circle, part which is enclosed by radius and arc, that is called sector. A region enclosed by radius and arc is called a sector of the circle. Okay, so here we are given the central angle is 20 degree for that sector and radius is 30 feet. So given theta is 20 degree and radius is 30 feet. Okay, now we will use two formula here. Those two are area of circle, which is pi r square. R is radius. And another one is area of a sector with angle theta. Area of sector with angle theta, that is theta by 360 degree multiplied by pi r square. Okay, now let's start solving this question. So here area of circle is pi multiplied by 30 whole square. So square feet, this is square feet. So that is 900 pi square feet. Next, area of sector with angle 20 degree. Area of sector with angle 20 degree, that is 20 by 360 degree multiplied by 900 square pi square feet. So here we can write 9 4s are 36, 100, 25, so 50 pi square feet. Okay, now what will be the area for the rest of the part if we remove that sector with 20 degree? So area of a new region, area of new region, area of the circle 900 pi minus area of that sector with angle 20 degree, 50 pi. So it is 850 pi square feet. So here the answer is option D is the correct answer. That is 850 pi square feet. In question number 78, we are given with ABCD is a parallelogram where AC and BD are diagonals. I have only drawn BD here. If BAD is 60 degree and ADB is 90 degree, then what is BD square equal to? So we are given that angle BAD is 60 degree and angle ADB is 90 degree. From trigonometry, we know sine theta is perpendicular by hypotenuse. Okay, and the value for sine 60 degree is √3 by 2. So here, if we consider triangle ABD, since this is a right angle triangle, and if we consider angle A, then according to that angle A, sine A is BD by, okay, it's not BD, it's, yes, BD by AB. I've written it correctly, BD by AB. Since we are considering angle A, so here AD is the base and BD is the perpendicular, AB is the hypotenuse. So BD by AB, now sine A means sine 60 degree, BD by AB. So here sine 60 degree √3 by 2. Okay, so we can write it as BD by AB. Since we are asked to find BD square, let's square both the side. We will get 3 by 4 AB square. So we can say that BD square is equal to 3 by 4 of AB square. We don't know the value for AB, we will keep it as it is. So here 3 by 4 AB square, option B is the correct answer here. In question number 79, it is given that a line through the vertex A of a parallelogram ABCD meets DC in P and BC produced in Q. If P is the midpoint of DC, then which of the following is or are correct? Area of PDA is equal to that of PCQ, and area of triangle QAB, the greater one, is equal to twice that of triangle PCQ. Select the correct answer using the code given below. So the concept we are going to first use here, first of all, here triangle ABQ and triangle PCQ, these two are similar triangles. Similar triangles. Okay, because by AA criteria we can say here angle Q is same for both the triangle, and since this is a parallelogram, so AB parallel to CD, correct? And here we can say this is a transversal. AQ is a transversal, so that means this two are corresponding angles. So here, according to AA similarity, we can say these two triangle are similar triangle. And since they are similar triangle, their ratio of their areas is equal to the square of the ratio of the sides. So here area of triangle ABQ by area of triangle PCQ equals to AB by PC whole square, or equals to BQ by CQ whole square, or equals to AQ by PQ whole square. Okay, now let's start with the main solution. Here P is the midpoint of CD. P is the midpoint of CD. Therefore, we can write DP equals to PC, correct? And also you can see there is a Z forming. Look at this Z. This is the Z we can form here. This is the Z, right? So that means AD parallel to CQ, because CQ is the extended part of BC, which is parallel to AD. Now at the corner of this Z, two angles form their alternate angles. So we can write, therefore, angle PAD equals to angle PQC alternate angles. Next, similarly, we get angle ADP equals to angle QCP, that is also alternate angles, right? Now we can say this is a congruent triangle. This to a congruent triangle, triangle PDA congruent with triangle PCQ. So here ADP, this two triangle and this two. So AAS criteria, we can say these two triangle are congruent. Since they're congruent triangle, their area is same. So area of triangle PDA is equal to area of triangle PCQ. So look at the first statement, area of triangle PD is equal to that of triangle PCQ. So here statement 1 is correct. Statement 1 is correct. Okay, next, similarly, we can write triangle ABQ and triangle PCQ. Let me show you here. Triangle ABQ and triangle PCQ, they are similar triangles. I have already written it. Q are similar triangles. Correct. So area of ABQ, the ratio of area of triangle ABQ and triangle PCQ, let's say this is equal to AB by PC whole square. Since P is the midpoint of CD and AB and CD equals to equal. Why? Because ABCD is a parallelogram. Opposite sides are parallel and equal. So AB equals to CD. So we can say AB is twice of PC here. So we can say AB is, since P is the midpoint, twice of PC. Correct. Now let's put this here in place of AB, twice of PC by PC whole square. So both PC will got cancelled. We will get here 4 by 1. 4 is to 1. Okay. Therefore, area of triangle ABQ is 4 times of area of triangle PCQ. Okay, so the statement here he's given in the second one, area of ABQ is equal to twice that of PCQ, which is not correct. Here we can see that is 4 times. So statement 2 is not correct. Statement 2 is not correct. Only statement 1 is correct. So here one option A is the correct answer, that one only. So let me again show you the whole solution. A very good question here. In question number 80, it is given that how many cubic meter of earth is to be dug out to dig a well of radius 1.4 meter and depth 5 meter. First of all, a well is always in the shape of a right circular cylinder. Okay, so a well is in the shape of right circular cylinder. So here we are given with radius 1.4 meter and depth, that means the height or the depth. So here and depth we can assume it as h, that is 5 meter. So the quantity of earth that is going to dug out, that will be equal to volume of the cylinder. So therefore quantity of earth dug out, that is equals to volume of cylinder. Okay, so we know what is the formula for volume, for finding volume of a cylinder, that is pi r square h. Okay, so if this is a cylinder, this is a cylinder, here r and this is h, so volume is pi r square h. Here we are given with r, that is 1.4 meters r square h multiplied by h, that is 5, and quantity of earth. Okay, so their quantity of earth, that is equals to volume of the cylinder. Now if we further calculate it, we will take pi as 22 by 7, 14 multiplied by 14 by 100 multiplied by 5, 50, 10 to 5 to 7. So it would result in 30.8 meter cube. Yes, so the result is 30.8 cubic meter. Option D is the correct answer here. In question number 81, we are given with, if the diagonals of a rhombus are x and y, then what is its area? So the formula we are going to use here, that is area of rhombus is half multiplied by product of lengths of diagonals. Okay, so we are given with the diagonals, length of the diagonals here. Diagonal is x and y. Therefore, area of it is half multiplied by x multiplied by y, that is xy by 2. Here, square units. Okay, so option E is the correct answer, xy by 2. In question number 82, we are given with the lengths of sides of a triangle are 3x, 4 root y, 5 cube root z, where 3x less than 4 root y less than 5 cube root z. So here 3x is the smallest, right? Now, if one of the angles is 90 degree, then what are the minimum integral values of x, y, z respectively? As one of the angles of a triangle is 90 degree, so we can say that the triangle is right angle triangle. Now, since the triangle is right angle triangle, so the length of the sides will form and satisfy a Pythagorean triplet, a Pythagorean theorem. So the length of the sides will form a Pythagorean triplet. So the the Pythagorean triplet with the minimum values, that is 3, 4, and 5. These are the number which form a Pythagorean triplet, and this is the minimum integral values. Also here we are also finding for minimum integral values. So smallest side is 3x, correct? So 3 should be equal with 3, that is the smallest value here. X equals to 1. 4 root y should be equals with 4, root y 1, so y equals to 1. And next 5 cube root z equals to 5, that is cube root z equals to 1, so z equals to 1. So here we can see the minimum integral values of x, y, z, 1, 1, 1. Now option C is the correct answer here. In question number 83, we are given with what is the maximum number of circumcircles that a triangle can have? First, let's remember the definition of a circumcircle. A circle that passes through all the vertices, all the 3 vertices. A triangle has 3 vertices. So all the 3 vertices of the triangle is known as the circumcircle of the triangle. Circumcircle of triangle. Let me draw it first. So if this is a triangle, circumcircle will touch all the vertices. So this will be a picture of circumcircle. Now the question is maximum number of circumcircles a triangle can have. As we can see, only one circle can be drawn by using 3 points. Only one circle can be drawn by using 3 points. So hence only one circle is possible for a triangle. So here option A is the correct answer. In question number 84, we are given with if an arc of a circle of radius 6 cm subtends a central angle measuring 30 degrees, then which one of the following is an approximate length of the arc? I have already drawn a figure here. O is the center of the circle, 6 cm is the radius. So let's first discuss the concept. If an arc subtends theta angle at the center, then length of the arc, the formula for finding length of the arc, that is theta by 360 degree multiplied by 2 pi r, where r is radius of the circle. Correct? Here we are given an arc of a circle of radius 6 centimeters. So here r is 6 centimeter. Now we have to find the length of AB. Here AB is the arc, correct? So length of AB, that is, now 30 degree angle measurement is given, central angle measurement. So here 30 degree by 360 degree multiplied by 2 pi r. Okay, let's solve this question now. So here length we got 22/7. In decimal we can write it as 3.14 centimeter approximately. Approx. In the options here, option E is the correct answer. That is 3.14 centimeter. That is the length of the arc. In question number 85, we are given with a ladder 5 meter long is placed in a room so as to reach a point 4.8 meter high on a wall. I have already done with the figure, and on turning the ladder over to the opposite side of the wall without moving the base, D is the base of the ladder. Okay, it reaches a point only 1.4 meter high. What is the breadth of the room? So we have assume that let x meter and y meter be the distance of the foot of the ladder from two opposite walls. Two opposite walls as shown in the figure. Here we are getting two right angle triangle. One is AED, another one is BCD. So the length of the sides will satisfy Pythagoras theorem. Now applying Pythagoras theorem, here in triangle ADE, we can write x square plus 1.4 whole square equals to 5 square. From here, we can get the value of x, that is root under 25 minus 1.96, root under 23.04, that is 4.8 meter. We got the value of x. Next, if we consider the triangle BCD, we can write y square plus 4.8 whole square equals to 5 square, because here CD and DE both are the same ladder. Okay, so they are of 5 meter. Now y equals to 25 minus 23.04, 1.96, that is y equals to 1.4 meter. So the value of y is 1.4 meter. Therefore, breadth of the room, so x plus y, x is 4.8 plus 1.4, 6.2 centimeter. That is 6.2 centimeter. Here option C is the correct answer. 6.2. Okay, not centimeter, 6.2 meter. Please make the correction. This is meter, not centimeter. 6.2 meter. In question number 86, the question is given, what is the area of the largest square plate cut from a circular disc of radius 1 unit? I have drawn a circular disc of radius 1 unit, and from this circular disc, this type of, this is the largest square that can be taken out. Here, the radius of this circular disc is 1 unit. Now the concept that we are going to use, diagonal of the square, as you can see already in the figure, diagonal of square is equal to the diameter of circular disc. Okay, now the largest square plate can be taken out from the circular disc like this way. So here, diagonal, if the side of the square plate, if we assume it as a unit, okay, so we know that diagonal of the square that is equals to diameter of the circular disc. If radius is 1 unit, so diameter is 2 into 1 unit, that is 2 units. Correct? Now we know the formula of side and the diagonal of a square. If side is a, then diagonal should be a root 2. Okay, this is all about square, a root 2. Now here diagonal of the square becomes 2 units, right? Therefore diagonal equals to root 2 multiplied by side of the square. So here 2 is root 2 multiplied by a. So the value of a is 2 by root 2, that is root 2 units. So we got the side of the square, root 2 units. Now area is side whole square. So root 2 whole square, that is 2 square units. So area of the square we got, that is 2 square units. Option D is the correct answer. In question number 87, we are given with out of 4 identical balls of radius r, 3 balls are placed on a plane such that each ball touches the other 2 balls. Look here, I have already drawn a figure here. These 3 circular shapes touching each other. The 4th ball is placed on them. Okay, it will be a 3D shape, which I won't be able to show here. Upon that, there will be another ball. If I try to draw another figure on it, there will be another ball. Okay, the 4th ball is placed on them such that the ball touches all the 3 balls. What is the distance of the center of the 4th ball from the plane? Now look at this figure. As we can see here, if the centers of 3 balls, if the centers of these 3 balls placed on a plane, placed on the plane are joined, as we can see, they are joined, it will form an equilateral triangle. It will form an equilateral triangle of side 2r units. How? Look here, this is r unit. They are all identical balls. That means their radius is same. So r, 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 r. So one, each side becomes 2r units. Okay. Now, if the center of the 4th ball is joined to these 3 centers, if the center of the 4th ball is joined to the 3 centers, a triangle or a triangular pyramid. Actually, if we place another ball on top of it, a triangular pyramid will be formed. Whose base is a equilateral triangle. Whose base is this triangle. This is an equilateral triangle whose base is a equilateral triangle. Okay. Now, base of a triangular pyramid, that is an equilateral triangle. So we got it. Now, height of a triangular pyramid. Let's find. How can we find height? Height of triangular pyramid, the formula is root under 2 by 3 multiplied by base side. Okay, so here base side is 2r because that equilateral triangle is of 2r units. So 2 by root under 2 by 3 multiplied by 2r units. Here we can write 2 root 2 by root 3 r units. This is the height of the triangular pyramid. Okay, now this is equal to the perpendicular distance of the center of the fourth ball. This is equal to the perpendicular distance of center of fourth ball to the line joining the centers of the other balls. Okay, next the distance of the center of the fourth ball, therefore the distance of center of fourth ball from plane can be computed by adding the radius of the ball to the distance. Here we are required to find the distance of the center of the ball from the plane, right? So the distance of the center of the fourth ball from the plane is the height of the triangular pyramid plus the radius. So if we solve it, we will get root 3 r by root 3. So 2 root 2 plus root 3 by root 3 r units. Here option D is the correct answer. Root 3 plus 2 root 2 by root 3 r unit. In question number 88, it is given that a right circular cylinder just encloses a sphere. I have already drawn a right circular cylinder. Inside that there is a sphere. If P is the surface area of the sphere and Q is the curved surface area of the cylinder, then which one of the following is correct? So we are given with the measurement of the surface area of the sphere, that is P, and Q is the curved surface area of the cylinder. First, let me discuss the formula of finding curved surface area for sphere and cylinder. So curved surface area of sphere, the formula is 4 pi r square. Okay, here r means radius. I can write it as radius square. Also, curved surface area of cylinder, that is 2 pi r h. Here 2 pi r is the radius, this is the radius, and h is the height. So radius and height. Okay, now if a sphere is enclosed in a cylinder, so when a right circular cylinder encloses a sphere, look at this figure. So the radius of the sphere and the cylinder must be equal. When a right circular cylinder encloses a sphere, the radius of sphere and cylinder must be equal. So both are having same radius. And what will happen with the height? First of all, the radius and the height for the right circular cylinder is same, correct? So here the height of the cylinder will be the height of the cylinder is equal to the diameter of the sphere, equal to the diameter of the sphere. Now, if I say the radius is r units, let's say radius of sphere, that is r units. So what will be the height of the cylinder? Height of cylinder, height of cylinder will be equal to the diameter. Diameter of the sphere will become 2r. So that is 2r units. Now let's use this formulas here. Curved surface area of a sphere, that is 4 pi r square. So here 4 pi r square equals to P. P is the curved surface area for the sphere. Okay, let's name it 1. And curved surface area for the cylinder 2 pi r h. R and height is 2r again. Okay, so that means it will become 4 pi r square. So this is the curved surface area for cylinder, that is equals with q. Let's name it equation number 2. Now from seeing the numerical value, we can see here that therefore P equals to Q. Look at their value. They are giving us the same expression. Both are 4 pi r square. That means P equals to Q. So from here we can say P equals to Q. So here this must be equal sign. Option A is the correct answer. Option A is the correct answer. In question number 89, it is given that ABCD is a quadrilateral such that AD equals to CD equals to CA. So I have already done with the figure. These all are 20 units, whereas BC is 12 units. Let's name it BC. BC is 12 unit. Okay. And angle ABC is 90 degree. What is the approximate area of the quadrilateral ABCD? So we can see this quadrilateral ABCD is a combination of equilateral triangle. ACD is equilateral triangle because all the sides of this triangle is equal, and a right angle triangle because here ABC is 90 degree. So we will first separately find the area for both of them and then add them to get the area for the quadrilateral ABCD. Here, area of equilateral triangle. Now let me discuss the concept first. Area of equilateral triangle. So that we can say there is a particular formula, √3 pi 4 multiplied by side whole square. Okay, same way area of right angle triangle, that is half into base into height. These are two formulas. So here we are given with triangle. If we consider triangle ABC, this is right angle triangle. Since angle ABC is 90 degree, this is right angle triangle. Okay. Now here we don't know the value for AB. So we have to first find the value for AB. Now applying Pythagoras theorem, we can write AB square equals to AC square minus BC square, that is 20 whole square minus 12 whole square. Therefore, we can write AB equals to root under 400 minus 144. That would result in root under 256. So that means 16 unit. 16 units. Okay. Okay. So here AB is the height. This is the height we can see, and this is base. So we can easily find the area. So here area of triangle ABC, half into base into height. Okay, so 8, that is 96 square units. Fine. Now we will consider triangle ACD. Consider triangle ACD. Here AC equals to CD equals to AD, that is 20 units. So this is equilateral triangle. This is equilateral triangle. Okay, now let's find the area of triangle ACD. Root 3 by 4, side squared, side is 20. So 4 5s are 100, 100 root 3. Now we will put the value for root 3 here, that is 1.732, 1.732. So it becomes 173.2 square units. Okay, now let's find the final area of quadrilateral ABCD. Now add this two value, 96 square units. We will get 962.2, approximately 269 square units. So what is the area of quadrilateral ABCD? That is option A, 269 square units. Have a look on the solution again. In question number 90, we are given with a diagram, and the question is associated with that. Let PQRS be the diameter of a circle of radius 9 centimeter. The length PQ, QR and RS are equal. Semicircle is drawn with QS as diameter as shown in the given figure. What is the ratio of the shaded region to that of the unshaded region? Here we are given that the diameter of the circle is diameter of the circle is a circle of radius 9 centimeter. I mean PQRS is the diameter and radius of the circle is 9 centimeter. So here we can say the length PQ, QR and RS are equal. Semicircle is drawn with QS as diameter. In question number 90, we are given with there is a diagram and the question is associated with this diagram. Let PQRS be the diameter of a circle of radius 9 centimeter. The length PQ, QR, RS are equal. Semicircle is drawn with QS as diameter as shown in the given figure. Then what is the ratio of the shaded region to that of the unshaded region? So here we are given that the diameter PS is 9 centimeter. This diameter has been divided into 3 equal parts, that is PR, PQ, QR and RS. Therefore, we can say PQ, QR and RS, these all are 3 centimeter each. Correct. Now let's remember what is the formula for finding area of semicircle. Area of semicircle, the formula is pi r square by 2, where r is radius, r is radius of the circle. So if I try to find the area of the semicircle PRS, I mean the upper this semicircle, so it will become semicircle area of semicircle here PRS, that means pi by 2. Here r how much? Okay, so here r is, we can say if diameter is 9, so r will be 9 by 2. 9 by 2 whole square. It will be square units. Let me first calculate with it. 81 pi by 8 square units. Okay, now the upper semicircular part into divided into two parts. One is shaded, one is non-shaded. So this non-shaded QR is semicircle. So here R is 3 centimeter. That means this semicircle is of radius 3 centimeter. Let's find the area. Area of semicircle QRS, that is pi by 2. Here radius we are given, that is 3. So 3 whole square, that means 9 pi by 2. Okay, square units. Now we are going to find the non-shaded part, the shaded part. This is the non-shaded part. We are going to find the area of the shaded part. How can we do that? If we subtract this QRS area from the area PRS, we'll get the rest of the part. So here, area of shaded region, that is 81 pi by 8 minus 9 pi by 2. Let's take common pi by 2. It will become 81 by 4 minus 9. So pi by 2, 36 by 4. It will become 45 pi by 8 square units. Okay. Now look here, how much portion is unshaded region? This semicircle and this semicircle. Now we will add them to get the area of unshaded region. Unshaded region. So area of QRS, that is 9 pi 2 plus area of the semicircle. Here, if we name it, let's say PTS, so that is also equal to PRS. So 81 by 81 pi by 8 square units. Now 836 pi plus 81 pi 117 pi by 8 square units. Now we will find the ratio. Therefore, ratio of shaded region to unshaded region. So here is 45 pi by 8 is to 117 pi by 8. That becomes 45 by 117. If we further simplify it, we will get the value 5:13. So yes, 5:13 is the correct answer here. Option B is the correct answer. In question number 91, we are given with the figure, what is the area of the shaded region? This is the shaded region here in the given figure. If the radius of each of the circles, there are 3 circles given in this figure, is 2 centimeter. That means here this part is 2, this part 2, these parts are 2 centimeter. We will start with the solution, but before we will write some formulas that we are going to use here. So those are area of equilateral triangle, that is 3 by 4 multiplied by side whole square. Also area of a sector with angle theta. First of all, what is sector? Okay, since this is a equilateral triangle, we know each side is 60 degree. Okay, this all sides are 60 degree. Now the sector is a sector of a circle is a part where it is enclosed by 2 radius, this 2 radius and 1 arc. So these 3 parts are sector here. Okay, how to find the area of the sector? That is theta by 360 degree multiplied by pi r square, where r is radius of that circle. Now here radius of the circle is given 2. Now if we add this 2, we will get the side AB, which is 4. So side, therefore side of triangle ABC, that is we can see 4 centimeter. 4 centimeter. So we can easily find the area of triangle ABC, root 3 by 4 centimeter square. Okay, so here it will become 4 root 3 centimeter square. Now look at this 3 sectors. We can see there are 3 sectors. So here area of the sectors, first of all, this theta is the central angle. How much is the central angle? 60 degree. So here theta is 60 degree. So 60 degree by 360 multiplied by pi, r is 2 whole squared. Now, how many such sectors are there? 1, 2, 3. 3 such sectors are there. So we will find the total area, we will multiply it by 3. So here, that is also centimeter square. Now 6. So 2, that means pi 2. So it becomes 2 pi centimeter square. Now this shaded part is, if we taken out these 3 sectors from the triangle, we will get only, we left out with only the shaded part. So here area of shaded region, that is area of triangle minus area of sectors. Okay, so here we will get 4 root 3 minus 2 pi centimeter square, because area of triangle is 4 root 3 centimeter square and area of sector 2 pi. So 4 root 3 minus 2 pi centimeter square. Here option A is the correct answer. In question number 92, we are given with a figure. In this figure, what is the area of the shaded region? So there is a circle. Inside of the circle, there is a rectangle, because we can see opposite sides are equal. Okay, so this is a rectangle. Also, this is 90 degree. Now, we are given with, if we name this, let's say A, B, C, D. Okay, now we will mark the center O in between. First join BD, the diagonals BD, and also AC. Let's join AC. Okay, so here where these two diagonal meet each other, that is the center of the circle, which is A, which is O, not A, sorry. Let O be the center of the circle. Okay, now let me put a perpendicular from O on AB. Okay, let's name it X. So here in the figure we are given that AB equals to CD, that is 6√3 units, and also AD equals to BC, that is 6 units. Okay, now since all the sides are 90 degree, so we can apply Pythagoras theorem in this BCD or ABD in this right angle triangle. So applying Pythagoras theorem in triangle ABC, we can see AC square equals to AB square plus BC square, that is AB 6√3 whole square plus 6 whole square. So 108 plus 36, 144. Therefore, AC equals to root under 144, 12 centimeter. Okay, now AC is the diameter of the circle. Therefore, radius of the circle, that is OA, half of the diameter. So 6 centimeter. So this is also 6 centimeters. Okay, now considering triangle AXO, this triangle, considering triangle AXO, we can write here cos angle AOX equals to, if we are considering this angle, that means OX is the base, OX by OA. Okay, so here also, okay, first of all, we have to find the value for OX as well, right? Now look at OX. OX is half of BC. Okay, so we can write here OX equals to half of BC, 6 by 2, that is 3 centimeter. Now here 3 by 6, so we will get half. Now cos AOX equals to half. Now in which acute angle cos give us half? We know at 60 degree. So cos 60 degree. Therefore, we can say angle AOAX 60 degree. This much portion is 60 degree. So what will be the value for this total AOB angle? It will be double. So central angle of sector, this is a sector. Why? Because OA and OB, these two radius and enclosed by these two radius and the arc AB. So this is a sector. So central angle of sector AOB of sector, so that central angle is AOB, which is 60 degree multiplied by 2, 120 degree. Now let me make you remember how to find the area of a sector with angle theta. So the formula is area of sector with angle theta, theta by 360 degree multiplied by pi multiplied by radius whole square. Here theta is 120 degree. Okay, and radius is as we know, 6 centimeters. 6 centimeter. Therefore, area of this sector is 120 degree by 360 degree, 22 by 7, and 6 multiplied by 6. So 3, 2, it will become now pi. So 12 pi centimeter square. Area of this sector is 12 pi centimeter square. Now, we can find the area of this triangle AOB. Okay, let's try to find it. Area of triangle AOB. We know the formula is half into base into height. So here half into base is AB. If AB is the base, OX is the height. So AB 6 root 3 multiplied by 3. That will give us the value 9 root 3 centimeter square. Now look at the figure again. So this shaded region, how can we find the area? If we subtract this unshaded region from this sector, we'll only left with this shaded part. So here area, therefore area of shaded region, area of the sector 12 pi minus area of the triangle 9 root 3 pi centimeter square. We can take common 3, not pi here, 9 root 3 only. So 3, it becomes 4 pi minus 3 root 3 centimeter square. So option, okay, here 3 multiplied by 4 pi minus 3 root 3 centimeter square. So option B is the correct answer. Okay, one more thing. I have taken centimeter. No, I shouldn't taken centimeter. Please make the correction. All where it will be units. Okay, all where it will be units. They haven't mentioned it particularly that whether it's centimeter or not. I should rectify this as well. This will be units. Okay, so it will be square units. This is as well square units. Square units, and this is as well square units. So formula answer is 3 multiplied by 4 pi minus 3 root 3 square units. Okay, option B is the correct answer. In question number 93, we are given with another figure. If y by x equals to 6 and z by x equals to 5, then what is the value of x? Here we can see this x, y, z, these are linear pairs, because if we add them, we'll get a straight angle. So from the given details, we can write y by x equals to 6. That means y equals to 6x. Also, z by x equals to 5 means z equals to 5x. So from the details, we can see x plus y plus z, we will get 180 degree. They are linear pairs. If we add them, we will get a straight angle, that is 180 degree. Now replace y by 6x and z by 5x. So 12x 180 degree and x equals to 15 degree. So yes, we got the value for x, that is 15 degree. Option C is the correct answer. In question number 94, we are given with ABCD is a trapezium where AB is parallel to DC, and if AB is 4 centimeter, BC is 3 centimeter, CD is 7 centimeter, and DA is 2 centimeter. Then what is the area of the trapezium? So here the parallel and non-parallel sides, all the lengths are given, right? So let me first discuss with the concept here. If A, B, C, D, these are the lengths of two parallel and non-parallel sides and non-parallel sides of trapezium, then the formula we can use for area of trapezium, that is A plus B by K. What is K? I will definitely explain it here. Multiplied by root under S minus K, S minus C, and S minus D. Now the question is, what is K and S, right? So here K is B minus A and S is K plus C plus D by 2, right? So first we will one by one calculate the value of K. So here A is 4 centimeter, B is 7 centimeter, okay. Next, C is 3 and D is 2. So we can find the value of K, that is B minus A, 7 minus 4. So it's 3. Okay. And the value for S is 3 plus 3 plus 2 by 2, 6, 8, 4. Now easily we can find, hence area of trapezium, that is A plus B by K, that means 4 plus 7 by 3. Okay, so first we will write 4 plus 7 by 3. Now we'll put the square root is 4, 4 minus 3, 4 minus 3, and 4 minus 2. So here the value is 11 by 3 also. If 4 comes out, we'll get 2 and 1, 1, 2, root 2. So now it becomes 22 by 3 root 2 centimeter squared. This is the answer. Yes, so here 22 root 2 by 3 centimeter square, option D is the correct answer. In question number 9, we are given with a figure, okay, and you can see there are angles highlight, name it as 1, 2, 3, 4, 5, 6, 7, 8. Angles are shown in the given figure. So what is the value of the sum of all these angles? I have named them as A, B, C, D. Now, we already know that the opposite angles formed by two intersecting lines are equal. Okay, opposite angle are equal. And next, another concept we already have learned, that is the sum of angles of a triangle is 180 degree. Okay, now we will use both of them. How? Look at the angle BAD, this angle. So since these two lines are intersecting, so obviously these two angles are vertically opposite angle, that means they are equal. Also here, this is a triangle, so all the sum of this angle 1, angle 2, and this A angle is 180 degree. So from this figure, we can write from this figure, we can write angle BAD is equal to 180 minus angle 1 plus angle 2. Same way, angle ABC is equal to 180 degree minus angle ABC. We can write here 7 and 8, angle 7 and angle 8. Okay. Same way, angle BCD is 180 degree minus BCD 1856. So here angle 5 plus angle 6. And for next ADC, angle ADC, that is 180 degree minus, so that is 3 4 180 degree minus angle 3 and angle 4. Correct. Now since this is a quadrilateral, this ABCD, it's a quadrilateral, so always the sum of angles of interior angles of a quadrilateral is 360 degree. Correct. Now adding all these angles, we will get BAD plus angle ABC plus BCD plus angle ADC, that is 720 degree minus, after taking common, minus angle 1, angle 2, angle 3, angle 4, 5, 6, 7 and 8. Now sum of angles of a quadrilateral is 360 degree. Sum of angles of a quadrilateral is 360 degree. Correct. Therefore here I can write 360 degree. So 720 degree minus the rest part will be same. So here we can write therefore angle 1 plus angle 2, angle 3, angle 4, 6, 7, 8. So 720 degree minus 360 degree, we will get another 360 degree. So sum of all this angle is 360 degree. Here option B is the correct answer. In question number 96, we are given with a figure. In this figure, PQ is parallel to RS. PQ is parallel to RS. Okay, and angle AEF is 95 degree, BHS is 100 degree, and angle ABC is given as X degree. Then what is the value of X? First of all, the concept you are going to use here, that is when two lines are parallel, corresponding angles are equal. Okay, the first one, the second one, sum of interior angles of a triangle is 180 degree. Sum of interior angles of triangle is 180 degree. And the last one is sum of two linear pair angles is again 180 degree. Now if I look at the figure, so here PQ and RS, these are parallel, right? So that means AB is transversal. AB, if I write transversal. Now look at the figure. So AEF and E or AGH, these two are corresponding angles. They are at the same corner position. So here angle AEF equals to angle AGH. They're equal because of corresponding angle. Correct. That means we can write it as 95 degree. So this is also 95 degree. Now look here. Uh, now this two angle. Okay. So here BGH and AGH. BGH and AGH. These two are linear pair. Okay, linear pair. That means the sum of these two angle is 180 degree. The sum of these two angle is 180 degree. Therefore, we can write BGH is 180 degree minus 95 degree. That is 85 degree. Okay. Great. Now look at the next one. Here BH is 100 and also BHG. These two are linear pair again. So BH is angle BH is and angle BHG are linear pairs. Linear pairs. That means this two, the sum of this two is the sum of this two is 180 degree. So from here I can write angle BHG 180 degree minus 110, that is 70 degree, correct? So this is 70 degree because we know since BHS is 110 degree. Therefore, now here this is a triangle BGH, triangle BAG. We know the sum of all three angles is 180 degree. So we can write x plus 85 degree plus 70 degree equals to 180 degree, or x is 180 degree minus 115. So we can write 25 degree. The value of x is 25 degree, or the value of ABC is 25 degree. Here option B is the correct answer. In question number 97, we are given with a figure where AB is parallel to CD. AB is parallel to CD and AC is parallel to BG. And also angle EAC 40 degree, angle FDG 55 degree, and angle HAB x degree. Then what is the value of x? So we already know when two parallel lines intersect each other, then the corresponding angles formed, they are equal. Also, sum of co-interior angle is equal. Sum, okay, not equal, 180 degrees. Sum of co-interior angles is 180 degree. Okay, and also we know vertically opposite angles are equal. Vertically opposite angles are equal, and we can say one more thing, that sum of angles, another different concept that we are going to use here, that sum of angles in straight line, that is 180 degree. So now look here, as we can see that here AB parallel to CD, AB parallel to CD, and BG is transversal. BG transversal. So here this FDG is angle FDG is equal to angle FDC. Why? Opposite angle, vertically opposite angle, vertically opposite. So this is also 55 degree. Okay, so this is also 55 degree. Now we can say ABD, angle ABD and angle BDC. The sum of these two angles is 180 degree. Why? Because they are co-interior angles. Co-interior angles. Okay, so already we got FDC, that is BDC. Okay, FDC. Okay, not FDC. It should be BDC. Yes, this opposite one is actually we are denoting BDC. So here the angle ABD is 180 degree minus 55 degree. So 125 degree. So this angle is 125 degree, we can say. Now also AC parallel to BD, correct? AC parallel to BD, and here AB transversal. Now we will consider AB transversal. So same way, angle CAB plus angle ABD equals to 180 degree because they are co-interior angles. Because they are co-interior angles. Now CAB is 180 degree minus 125 degree. That will give us the value 55 degree. That means this angle A is 55 degree. Okay. Okay. And also we know angle EAC equals to angle HA. Okay, so this is HA. I mean this one. HA, let's say T. Okay, HAT. If I name it T, HAT, so we can name it 40 degree because they are vertically opposite. Vertically opposite. These two angles are vertically opposite. So this is also 40 degree. Now we can see there is a straight angle, correct? The angle, there is a straight angle. How can I name it? Okay, angle H, not H, angle A and I mean angle A and C. There is a straight angle we can see. So angle 40 degree X and 55 degree. Here angle 40 degree X and 55 degree, they are same angles on a straight line. So the sum of them will give us 180 degree. Sum of angles of a straight line is 180 degree. So they will give us 180 degree. Now from here, if we calculate, the value of X is again 85 degree. So angle X is 85 degree. Here option A is the correct answer. In question number 98, we are given with a figure. There are three semicircles, ABC, the upper one, here AEF and CDF. The distance between A and C is 28 meters and F is the midpoint of AC. What is the total area of these three semicircles? So since AC is 28 units, we can say AF is also half of AC, that is AF is 14 units as well as CF is also 14 units. Now the formula for finding area of a semicircle, that is area of semicircle, so that is pi r square by 2 square unit. We will use this here. Now let's talk about the semicircle ABC. For ABC, R is 28 by 2, that is 14 units. So area of ABC pi 14 square by 2. So it becomes 14 7. So it is 98 pi square units. Square units. Now for semicircle AEF, here R is, because AF is the diameter, correct? So R is 14 by 2 here. So that is 7 units. Now area of AEF, that is pi 7 whole square by 2. And also for CDF as well, CDF, semicircle CDF, R is again 7 units. Okay, so area of CDF, that is pi R square by 2. Therefore, sum of areas of 3 semicircles, that is 98 pi plus pi 49 by 2 plus pi 40. Okay, I should write here square units. Always mention unit, that is must. 9 by 2, from here I can write 98 pi plus 49 pi, that is 147 multiplied by 22 by 7, so 462 square units. So 462 is the correct answer. Option D is the correct answer here. In question number 99, we are given with, in this figure, there is a circle and inside there is a rectangle of length 8 centimeter and breadth 6 centimeter. What is the approximate area of the shaded region in the given figure? So we will use two formulas here. Those, that is area of a rectangle, that is length into breadth. Another one is area of circle, which is pi r square by 2, where r is radius of that circle. Okay, now we can easily find the area of the rectangle. So therefore, area of rectangle, that is 8 multiplied by 6 centimeter square, here 48 centimeter square. Now if I draw one diagonal of this rectangle, we will get to see that the diagonal is the diameter of the circle. That means diameter of circle is equals to diagonal of rectangle. Okay, so how to find the diagonal of the rectangle? Root under 8 square plus 6 square. Why? If you have look at this, there is a 90-degree angle. That means it becomes a right angle triangle. So we can easily use Pythagoras theorem. So it using Pythagoras theorem, let's say AB, the length of AB will be root under 8 square plus 6 square. Okay, and this is the diameter of the circle. So let's say 2r. If r is the radius, that means r is here 10 by 2, 5 centimeter. Now therefore, area of circle pi r square by 2. So pi, for the value pi, we can write that is 3.14. Here is 25 by 2. So it will be result in 78.5 centimeter square. Now, if we remove the rectangle, we will only left with the shaded region, correct? So that means area of shaded region, that is area of circle minus area of rectangle. So here area of circle is 78.5 minus 48. That would result in 30.5 centimeter square. So here correct option is option D. As we can see here, option D, 30.5 centimeter is the correct answer. In question number 100, we are given with consider the following statements with reference to the given figure. Here we are given with a trapezium ABCD, AC and BD. These two are diagonals meeting each other at the point O. Now, three statements are given to us. The first one is the sum of the areas of triangle AOD and triangle BOC is equal to the sum of the areas of triangle AOB and triangle COD. The second one is angle AOD equals to angle BOC. The third one is sum of side AB, BC, CD and DA is greater than the sum of side AC and BD. Which of the above statements are correct? We will check each of statement separately, each of them separately. First, we know that the opposite angles formed by intersecting lines they are equal actually, because they are vertically opposite angle, they are equal. Here we can see AC and BD, these two are intersecting lines. So these two angles are vertically opposite. That means angle AOD equals to angle BOC. Therefore, statement 2, the second statement, look at the second statement. So statement 2 is correct. Okay, next. Okay, so we can draw a line through A. Okay, let's name it X and Y. And we can say that length of XY is H unit. So let H units be the height of trapezium ABCD, and A, let's say AD is A unit and BC is B unit. Okay, and AB, okay, A units equals to AD and B units equals to BC. So here we can say that OX plus OY, that is H units, that is the height. Now, since we know the diagonal of a trapezium divides each other in proportion. Okay, so we can see here these two triangles AOD and BOC, triangle AOD and triangle BOC. Since these two are similar triangles, so their heights, therefore their heights are in the same proportion as their sides. So we can write OX by OY is AD by BC. AD by BC, that means A by B. Now if we apply addendo, that means let's say OX by OX plus OY and also A by A plus B. We are doing addendo. So here we can write OX equals to, since OX plus Y is H, that means H by A plus B. Okay. Also, if we write OX plus OY by OY, that is A plus B by B. So that means OY become BH by A plus B. So we got the height for triangle AOD and triangle BOC. We know how to find the area of a triangle, that is half into base into height. So area of triangle AOD plus area of triangle BOC, that is half into, okay, base is A and height is AH by A plus B, plus half into B multiplied by BH by A plus B. So altogether we will get the value, that is H by 2 of A plus B multiplied by A square plus B square. Okay, so let's name it equation number 1. Here area of AUD plus area of BOC. Okay, now the sum of this area is equal to the sum of the areas AOB and DOC. Correct? So now look, how can we find that portion area? Area of AOB, triangle AOB, plus area of triangle DOC, that is, if we subtract the area from the area of the trapezium, area of trapezium ABCD minus area of AOD and area of BOC. We know how to find the area of the trapezium, that is half into height into sum of the parallel sides, right? That means A plus B and minus here H multiplied by A square plus B square by 2 into A plus B. Okay, if we calculate, we will get the value as, let's say, let's take common H by 2. So it will become A square plus B square plus 2AB minus A square B square by A plus B. So we will get only ABH by A plus B. Let's name it 2. Okay, so this is the area of triangle AOB and this is the area of the sum of the triangle AOB and triangle DOC. Now, comparing equation 1 and equation 2, comparing 1 and 2, we can say the area of AOB and DOC is not equal with the area AOD plus the area of the triangle BOC. So hence the first statement, the sum of the areas of triangle AOD and triangle BOC is equal to the sum of the areas of triangle AOB and triangle DOC, that is not correct. So statement 1, is not correct. Okay, next. Okay, now let us discuss a concept of a triangle. That concept is the sum, we say triangle inequality, that is the sum of lengths of the two sides of a triangle is greater than the length of its third side. Right? Now look at the triangle ABD. In triangle ABD, we can write here ABD, we can write AD plus AB is greater than BD. Also in BCD, we can write BC plus CD is greater than BD. So here we can write AB plus AD greater than BD. And here also, not BD, let me check. It is, yes, it is BD. And in triangle BCD, we can write BC plus CD that is greater than BD. Now another two triangles we can take here. Let's say ABC. So AB plus BC greater than AC and AD plus CD greater than AC. So let me write it here. In triangle ABC, AB plus BC greater than AC, and in triangle ADC, AD plus CD that is greater than AC. Now, if we add these four inequalities, we will get twice of AB plus BC plus CD plus AD greater than twice of AC plus BD. If both the two got cancelled, we left with only AB plus BC plus CD plus AD greater than AC plus BD. Now look at the third statement given to us. AB plus BC plus CD plus DA greater than AC plus BD. That means, yes, it satisfied the third statement. Therefore, statement 3 is correct. So all together we got only 2 and 3 statement is correct. First one is wrong. So option B is the correct answer. 2 and 3 only correct. Look, I'm again showing you the whole solution. This is a very good question. The solution is a bit lengthy though, but yes.